Okay, so let's just kind of officially wrap this up and kind of summarize what we've learned. So for our three main functions, right, what's our domain and range? Well, again, since we want to talk about our trig functions, the domain and ranges have to change a little bit. Well, actually, the domain does, right? So for sine x, what we're doing is we're restricting the domain from negative pi over 2 to pi over 2. That's where it assumes its entire range from negative 1 to 1. So the range isn't being restricted, it's the domain, right? That way our inverse function exists. For cosine, what we did is we restricted the domain from 0 to pi, right? And that's where it went through its full range of motion from negative 1 to 1. And for tangent of x, what we did is we restricted the domain like we did for sine from negative pi over 2 to pi over 2. And of course its range is everything. Okay, and so what this means then is for the inverse sine function, right, we basically flip-flop the roles of the domain and the range. So the inverse sine is going to take any value from negative 1 to 1, and it's going to spit out or give an output from negative pi over 2 to pi over 2. So a negative rotation into quad 4 and a positive rotation into quad 1. The inverse cosine function, right, what it's going to do is its domain is going to take anything from negative 1 to 1, but what it's going to do is give us an output from 0 to pi. So positively rotating from quad 1 to quad 2. And the inverse tangent function, right, what it will do is it'll take any value and it'll create a value from negative pi over 2 to pi over 2. All right, and so to get their graphs, right, by hand, we basically use the fact that the data points are basically flip-flopping. So in this first, for this sine function, right, if we go from x, y, if we go from negative pi over 2 to, let's just say, negative pi over 4, and we go 0 and pi over 4 and pi over 2, right? We know the output for sine, this is sine by the way, we know the output at negative pi over 2, we get a negative 1. Here we get a negative square roots of 2 over 2, we get a 0, we get a square root of 2 over 2, and we get a 1. Alright, so that means that the inverse sine, what it does is it reverses these data points, right? Its input will be negative 1, negative square root of 2 over 2, 0, square root of 2 over 2, and 1, and then it's going to create these output values, respectively. Alright, so that would be the graph of my arc sine, right, or inverse sine. So if we graph these, right, we have pi over 2 is roughly about 1.5. So let me make that 1. Let's make that negative 1, right? And let's make that negative 1 and positive 1 respectively. So at negative 1, we're roughly about negative pi over 2, which takes us down in here. At 0, we're at 0. And at positive 1, we're a little bit over 1.5, right? Pi over 2. And then we at negative square root of 2, which is about 7.07, right? We're at negative pi over 4. So that's roughly about 0.75 and 0.75 respectively. So if we kind of create that, here's what your graph is going to look like, and that's going again from negative pi over 2 to pi over 2. Alright, so there's what your arc sine graph looks like when we restrict it on the domain. Of course, we can do the same thing for cosine, right? So for a cosine graph, some data points from 0 to pi. Well, 0, how about we just go pi over 2, pi, we should go pi over 4, pi over 2, 3 pi over 4, and pi. So cosine of 0 we know to be 1. This is the square root of 2 over 2. That's 0. That's negative square root of 2 over 2, and that's negative 1. And so the inverse cosine is going to basically reverse these values. So we get 1, 0, square root of 2 over 2, pi over 4, 0, pi over 2, negative square root of 2 over 2, and 3 pi over 4, and then we get negative 1, and we get pi. All right, and so graphing these, again, how about I break up this axis into negative 1 and 1 respectively, and how about, I'm going to do a little bit better than it over here, how about we break things up in terms of like pi over 2, right, negative pi over 2, and pi respectively. And so when we start graphing this, the inverse cosine, arc cosine, has 1, 0 on its graph. So it's got that value right there. All right? It's got the square root of 2, square root of 2. So this is about 0.707, right? And we're at pi over 4, which is half of pi over 2, right? And then at 0, we're at pi over 2. At negative square root of 2 over 2, which is again about 0.7, we're at 3 pi over 4, so about right there. And then at negative 1, we're all the way at pi. So here is what a graph of your arc cosine looks like from 0 to pi and negative 1 to 1. And then last but least, the arc tangent. When we look at some data points for a tangent, what we're looking at, right, is negative pi over 2 to pi over 2, we have an asymptote. At negative pi over 4, we're negative 1. At 0, we're 0. At positive pi over 4, we're positive 1. And at pi over 2, we're basically an asymptote, right? Positively and negatively. So what this means is the arc tangent, right, the inverse tangent, has to reverse these roles. So we have negative infinity asymptote and negative pi over 2. We have negative 1 and negative pi over 4. We got 0, 0. We got 1 and pi over 4, and a positive infinity at pi over 2. And so, again, looking at our axes, how about I just, again, let me make that negative 1 and 1 respectively. All right? That's positive 1. And then how about along these axes, I just, again, call this pi over 2 and negative pi over 2. And so at negative 1, we have a value of negative pi over 4. All right, so that puts us at negative 1, negative pi over 4, sorry. And then at 0, we're at 0. At positive 1, we're at pi over 4. And then at, we're going to go to negative infinity, right, as we approach pi over 2. So that action is going to do this. And then at an output of pi over 2, right, we're going to be going towards negative infinity. So there would be a graph of your arc tangent for what we have. Again, we're restricting our range from negative pi over 2 to pi over 2, and our domain can be anything from positive to negative infinity. And then just as a really quick check, right, here's my Desmos calculator. There's our tangent function, right, our arc tangent. Let me turn that off. Here's our cosine function. Of course, we know the value here, this is from 0 to pi, and from negative 1 to 1, right? And then sine, there's that graph of sine. So from negative 1 to 1, we're going from negative pi over 2 to pi over 2. So you can see that my graphs are pretty much right on the money. What's most important is you guys really need to, I guess, memorize them or whatever the case you need to do, right? When we're invoking our inverse sine, cosine, and tangent, we have to be very, very aware of, right, what I put into them, right, domain-wise, and then what we're getting out of them range-wise. We're getting a very, very restricted picture of what fully is going on. Alrighty, so let's get to work now that we've laid all that groundwork. Let's go start using this in some action and doing some problems.